Hello, and welcome to another episode of Hacking with Friends. My name is Kody Kinsey. I am a security researcher with Varonis, and this is Michael. He was raised by a camera from a young age and currently works on our production crew.
Accurate.
Now, today we are going to be doing something pretty cool. We're going to be working with a really low-cost SDR. Michael, what is an SDR?
Software-defined radio.
That's right. So what's really interesting about this thing we're going to be working with today is it didn't start its life out as a SDR. Michael, do you know the story behind the RTL-SDR?
Not all the details, but apparently it started off, the chip was designed to be one of those TV dongles. So it would allow you to watch over-the-air TV either on your computer, or you would like plug it into the back of your smart TV and it would allow you to see over-the-air TV transmissions that way. But then at some point, hackers and makers were playing around with it and discovered that, hey, wait a second, this can see like way more of the spectrum than just that tiny little bandwidth. So they started playing around with it and using it to monitor the airwaves, as it were. I don't really know like what exactly SDR is in relation to that, and like all the complex intricacies there, but yeah.
No, so that's a good place to jump off. So this particular RTL-SDR started out life as a TV tuner. And then, as Michael said, hackers figured out very quickly that the hardware inside this thing is actually great. It's kind of similar to the origin story of the ESP8266. It was a humble little chip that was developed for, a singular purpose, and then other people discovered like, hey, this is actually great at a bunch of other things too. So because these were mass produced and they're cheap, you can find them really easily. The one thing to note though is when you start using them for a frequency that it wasn't originally designed for, it gets hot.
Yeah, and that's why they have the aluminum heat sink on that one. Like,
yeah, you can get plastic ones that literally the frequency will start to drift as it gets hot because the chip really does heat up pretty quickly.
Yeah.
But what I love about these is you can get into a little bit of radio receiving hacking, which is safe and legal to do pretty much everywhere. And I think that's really cool. So
yeah, and it's pretty like dirt cheap too.
Exactly.
It's like 10 or 50. Well, no, I think it's like $30 for that or something.
Like 20 or $30 for one of these. You can find them on Amazon or other places. They really are a cool way to just plug into a computer and get started. Unless you're on Windows, which I found out today. But I did it. We're going to do this on Windows at least halfway today because I had to figure it out just to try out a couple software-defined radio programs I'd never tried before. So we're going to try out a couple different ones. So if this is your first time, then what can you do with something like this? Is it worth it to get one? What is the entire point? Well, the first thing that you can do is you can listen to the radio. So if you just want to listen to regular radio stations,
FM radio.
yeah, like FM,
like you would in your
or
car.
AM,
yeah,
doesn't matter. You can listen to FM, AM radio if you have a favorite radio station. If you like to listen to NOAA, if you like to listen to NPR, whatever, you can tune into that on pretty much any like Linux device, any Windows device, or Mac OS. So that in and of itself is pretty cool. It does more. So you can also tune into ham radio stations. So this is people who are either just communicating peer-to-peer or repeating stuff from other areas, which is interesting and cool. You can tune into scientific stations that you would normally need like a disaster radio or something. So that could be really useful. I found out about a fire one time by tuning into the fire station near me. And that's where we get into plain transmission. So just regular audio transmissions. Now, it's really surprising that when I was living in Los Angeles, the majority of agencies actually did stuff without even encoding it. It wasn't even encrypted.
Just like good old analog signal.
No, it was, yeah. So basically, yes. So the signal was not encoded in any way. And I could just tap into it. And yes, it looked like an analog signal. Not quite the same as AM, but still like a pretty basic signal that we can listen in on with just something like this. Yeah. So also if you have a radio like this, then you can listen in on conversations other people are having unless the radio is either encoding or encrypting the communications, which is more expensive. So most radios do not do that if they are just a simple radio that's not meant for some sort of like tactical application. And you'd be surprised, even radios that are meant for tactical applications sometimes don't encode their audio. So when I worked at a security venue, their radios did not encode anything. So anybody could listen in on our communications. And if they had a software-defined radio that also can transmit a transceiver, then they could also broadcast, which was a problem because people would prank us on our frequencies. So So to be clear, this is a receiver. It is not
Right.
a transceiver. You can't broadcast with it, but you can listen in on things like maybe like the local music venues security talking about all the stuff that they're doing, just
Yeah.
like when I was working at one.
Yeah, I definitely find that in like bigger cities or anywhere like that, you can just hop on this thing and just start scanning, and you will find like the most random things, like restaurants communicating. I did it in Las Vegas once, and you could hear like hotel security.
Oh yeah, we could hear hotel staff, hotel security.
Yeah.
You can hear helicopters talking to each other. You can hear airport transmissions. You can hear individual bus drivers complaining to each other.
Yeah.
You can hear taxi dispatch. It's really amazing the kind of stuff that you can hear, especially in like a bigger city. But even out in the sticks, you can still hear transmissions. You can literally hear like dudes in the woods like walking around hunting, like communicating on like two-way radios.
Yeah.
So it's a really interesting way of monitoring the spectrum around you, and there's a lot of different tools you can use to get started with it. And previously I was always recommending using either a Linux or a Mac OS computer, but so there is one limitation with this that we're not going to go into today, and that's not for lack of trying. I did try. We're not going to go into decoding digital audio, so like decoding speech that is encoded. Now that we're not breaking encryption. This stuff is encoded just so that it is received properly and packetized, and basically.
Don't you have to like use a GNU radio or something?
No, you have to use DSD, digital signal decoder, and or DSD plus, and DSD plus is Windows only, or you can try to run it in Wine on Linux, which is a nightmare, and I spent half of my day doing, and that's why I was so angry earlier. So yeah, I was not able to get DSD Plus running in Wine on Ubuntu. I tried it for a while, and if you can get it running, then that is the way that you would go ahead and do this. But I will go ahead and show you guys what DSD Plus looks like on this computer, although I don't think we'll be able to decode any audio today. Maybe for another day when my my patience meter has reset, I'll be able to approach this again.
Future live stream will do digital transmission. So this is basically just sort of like analog sound, so FM and AM transmissions.
FM and AM radio, and also we can listen to a lot of like stuff that's not human readable, but we can record it and then we can play it back or interpret it in another program. So a lot of this is like trunked radio systems, which is like logistics stuff, like trucks that are like reporting in logistics data. It's like a whole bunch of stuff that's all kind of automated, and it's pretty cool. So I'm gonna plug this in here. So one thing to note is we are in a basement, so it is pretty much the worst place you can be to listen in on anything radio related. But we're going to give it our best. And also I found that for whatever reason, the Windows version is, or at least the software-defined radio program I'm using is not as sensitive, and I couldn't find some channels that I could find when I was using a different program in Linux.
Yeah, and some things to keep in mind when you're plugging in this SDR is the SDR is only one component. The antenna is also important. So antennas are designed to be sensitive to certain frequencies. So when you're operating outside of those frequency bands, you're not going to be able to see signals even if they're there. Same thing with this SDR. It's designed to operate within a certain frequency band. And just a fun idea I had is a lot of people will have coax cables in their walls from cable TV. Well, if you're not using those, you could actually use that to put an antenna like in a window in a bedroom upstairs, use the coax, because the coax that's running through the cable is the same coax that these use. They're just transmitting analog signals. So you could, in theory, put an antenna anywhere in your house that you already have a coax connection to.
You want to attach an antenna to like just meters of like copper.
Right, yeah, you certainly will get a loss. So like if you were...
So an electrical engineer needs to talk to this man. I don't know enough to tell you why. I just I feel my electrical engineer teacher like in my brain telling me that's going to cause a lot of problems.
You'll get some loss. Like you can use an amplifier for that sort of stuff, but that's like what hams do, is they'll have an outside big, usually a disc cone antenna is very popular for SDR applications because it has a very wide amount of bandwidth available to it. So I can show you a picture later, but basically it looks like a TP, like a bunch of sticks down like this, and then a bunch of sticks out on a flat plane, and that's a disc cone antenna. Very good for these applications. But yeah, more you know.
The more you know. So we're using the famous what are they, rabbit ear antennas that are just like
Yeah. So like the ones you would imagine from an old-fashioned TV. And that works because you can change the length of each arm, and that'll help with specific frequencies as well.
Yep. Yeah, so this whole setup I think ran me like $40 or something on Amazon, and it was really easy to do. So yeah, overall it was really easy to get this set up once I figured out what I needed to do with Linux. And to be fair, the RTL-SDR website had a lot of good instructions for this, and when I actually followed them, it worked. But there's a lot of other instructions around the internet for doing this that are incomplete or do not work. So I'm going to recommend a couple sources that I found that made this a lot easier for me. All right, shall we switch over to my screen?
Yeah, I was actually going to show...
Oh, no, if you want to show the...
Hold up. Just... My screen had to reconfigure for a second. But, yeah, so... There we go. Before we go down the rabbit hole too far.
Whoa.
These are disc cone antennas I was talking about. Very popular because of their wide frequency band. You can see here. Basically 25 megahertz to 300 megahertz. So that would be basically all the radio spectrum that most people are going to listen to. And they're like $40-$50. So if you do get into this, that's the kind of thing you might consider getting good starting off position. But
yeah, but this okay.
Yeah,
but also this has very limited
bandwidth.
Well, like frequency
Range.
yeah.
I'll switch over to your screen.
Cool. Yeah, do it. Okay. Can we still see the what we're doing?
Yeah.
Okay. Cool.
We will in a...
All right. So let me go over to all right, so this is the quick start guide that I recommend you guys do if you want to grab one of these RTL SDRs. It is on RTL-SDR.com, and I admit that this makes it doable on Windows, which I'm on Windows, you guys. Look at this. I'm on Windows, just like you. Isn't that great? We're all on Windows. If you scroll down, you can see, there's the equipment list.
Yeah, they talk about some of the stuff in there as well.
And then we have a setup guide. So hooray, purchase your dongle. And then once you got your dongle, make sure you got this thing that should automatically be installed. Wonderful. Then go to airspy.com and download the Windows SDR software package. Great, go ahead and do that. It will download SDRSharp, which we'll use in a minute. We extract it, and we move all the stuff together. Wonderful, cool. Then we click on install RTL-SDR.bat. If you don't do this, it won't work. I found that out. You're welcome. So go ahead and install this. Hooray.
Yeah, I remember when I had to do this on my Windows system, it was a nightmare of reading the instructions very carefully.
Yeah. Okay, so you run this. Okay, wonderful. You've run this installation thing. It looks all sketchy, but trust it. Sure, it's from the internet. So then you plug in your dongle. Guess what? Your dongle's not going to friggin' work. Congratulations, you're stuck. Now you have to go download this other thing, Zding. There you go. Download Zding.x, which, by the way, sounds like a virus. I am, I don't know. I don't deal with a lot of Windows stuff, so Zding.x just rings to me like an attachment that I should ignore. But whatever, download it. It's from the internet. I'm sure, and then run it as administrator.
100% legit.
Yeah. Oh my God. But this did work, so hang with me, you guys. When Windows people, is this the way that everything works? If so, it sucks.
No, this is pretty hard.
All right, in Zding, go to Options, List All Devices, and make sure the option is checked. If you're in Windows 10, some cases you might need to uncheck whatever. Okay, so once you list all devices, then here, let me show you guys Zding.
Yeah. So the reason you're having to do all this is basically you're installing the drivers for this.
Oh my God, this is Zding. Okay, so when I have the RTL-SDR plugged in, it shows up as oh, it's frozen. Okay, well, just observe this static Zding. I can click on here, and it'll show up as bulk in interface 0. Now, I actually had two. I had interface 0 and interface 1, and when I unplugged the RTL-SDR, they both disappeared. So I had to do this twice. I did it on both of them, and maybe as a matter of coincidence, or maybe because that's required, when I did it on both, it finally worked. And what this is doing is it's replacing the original driver, which is wrong, which is misidentifying this as something else and causing it to not work, and fixing it so that these stupid SDR programs can actually see it. Yeah. Very annoying. Windows people, I'm so sorry. Really? Ugh.
Sad days.
Yeah. Okay. So, All right, now that we're done with Zding. Oh, this is a PNG of Zding. That makes me so happy because like I hate this program. We end up on SDRSharp. And SDRSharp is the program we're going to use. But let me make sure that I have not skipped ahead. Oh, wait, where's the...
Are you in the right tab?
Probably not.
That's an article.
Yeah. Let me just go back to the quick start guide. All right, so we're at the point where we've done our Zding.
Yeah.
So we've run it as administrator. We've listed all devices. We've selected bulk in. And then we've pressed replace driver. And then if your Windows doesn't go absolutely crazy, then it should work.
Big security.
So it's like, okay, hooray, you're done. So then you might need to just restart your whole computer because Windows works that way. And you should be able to open SDRSharp.x. And then in the sources, I'm sorry, Michael, or do you need to?
Windows is
allow
boring.
You to take a nap?
Mm-hmm.
All right. As soon as we look at the sources, we should see RTL-SDR USB. If it doesn't say USB and it says TCP, you've been tricked, lied to, and it didn't work. This was the case for me. And if you click on it anyway, then it just starts recording your own voice, and you can shout at the computer, and it's stupid. Okay, fun. Yeah. So let's see if this has worked. So we did our Zding. We did our .bat file. We're clicking on our super legit.exe file. Let's go ahead and see if we can run SDRSharp. All right, AirSpy, not the name of the exe I just ran, but who cares? All right, so here we can see that we have some sources. This it's automatically like a dark mode interface.
Yeah,
nice.
I like that.
Yeah,
dark mode's awesome.
Easily impressed, but okay. So then we have here a list of different sources, and all of them are expensive except for this one. HackRF, no thanks, buddy.
HackRFs you can get on like AliExpress as like knockoffs since they're open source for like $100.
Yeah. Oh, I have one actually, but let's try it. I mean, it's probably not going to work though because it's a knockoff.
I mean, the nice thing...
Anyway, there's like an AirSpy and some other crazier stuff, but we're just going to use this nice little RTL-SDR USB dongle. Okay, so that's selected. Now, the moment of truth.
Fire the weapon.
Fire the weapon. Hey, look at these double domes right here. Isn't that great?
Okay.
So we're not hearing anything. What's up with this? Well, for one, I muted my stuff. So let's unmute.
Hey, like that, nice. You got crappy radio.
It sounds like trash. Let's turn it down. And how do we fix this? Well, okay, let's look at a couple things we can do. For one, this is hard to see. So can we adjust this a little bit to see what's going on? Looks like a pretty weak signal, and it's also too wide. So there's a bunch of different ways we can display this data. Let me turn this down. So there's a bunch of different ways we can interpret this radio data. We can see here, for example, we have a little peak. I can click on it, and I can select which thing I want to listen in on by clicking on any particular peak. And if I want to zoom in, I can go to the zoom menu and just go right here, zoom in, and see if there's, well, anything to see. So I can zoom out the same way, and these other different things affect the offset and the way that it displays data. So, all right, let's go to this transmission here. Clearly this is not AM, but I can interpret it as AM if I want to. So the nice thing about this is I can choose to interpret like a channel that's totally not AM as AM. And let's say that I want to scroll through and just see. All right, so we're listening. So let's go ahead and see what happens when we listen to a radio channel with the wrong type of decoding. Let's zoom in a little bit. And by the way, I just want to say I am an amateur with SDR. So if I use the wrong terminology or if I otherwise misclassify something, sometimes the SDR community is a little unforgiving. I'm sorry, you guys. I like this stuff too. It's great, but I haven't dedicated as much time as you.
I'm merely mediocre at SDR stuff, so I can correct you somewhat.
All right, let's go ahead and take a look at the situation we got going on here. So you'll notice the waterfall at the bottom kind of updates as we change stuff. So let me turn it down some more. We can see we have a center frequency right here. I can bring it in a little bit. Let's see what it sounds like. Nothing. It sounds like nothing.
Yeah, I was going to say, so a lot of these FM stations will also have, like, I think what would be referred to as, like, subcarriers and subfrequencies. And that's where, you know, have you ever wondered on your radio how it knows what song is actually playing? That they send that signal digitally. So some digital signal hidden in the FM radio stations. Or that might also be those little peaks off to the side. I don't remember how exactly it worked, but that's how they communicate
Here we go.
that information.
Okay, so if I widen this, if I widen the range that we're listening in on, we can hear a bit more. Let's listen. That's pretty good, huh?
Yeah.
Yeah.
Best radio station.
All right, guys, we're done. So obviously something's wrong. If we switch this over to NFM, oh wait. Cool. No, I like it, but it's wrong. So if we switch to NFM,
It sounds like you're just being a bad
what does it
DJ.
sound like? It sounds like a distress call from space.
Yes. Yeah.
So that's wrong. Let's broaden it. This sounds like there's like a hidden message. Okay, so clearly this is wrong too. So let's go over to WFM.
What's going on here?
You're making the dishes rattle.
That sounds
Alex is having a nervous
beautiful.
break.
Okay, so that sounded a lot better. I'm gonna turn it down because I hate commercials. But in fact, like, what about if I wanted to listen to this just raw? Much better.
That's the native computer language right there.
Yeah, so we can. So let me turn this down. So basically what we're doing here is we're taking the same radio transmission and we're running it through different ways of decoding it. So we're trying wide FM, we're trying narrow FM, which is usually used for like point-to-point communications like with radios. We're trying AM, and then some of these other ones are for more automated or like digital types of communication.
Right.
So if you want to listen to some crazy ones that sound like space.
And if you don't know the difference between encoding, encrypting, and hashing, then be sure to check out our previous live stream on that subject, and some of this will make a lot more sense to you.
Very spooky. This one's
Yes.
one of my favorite. It makes everything sound spooky. So, okay, what are we doing here? Well, we're basically making it so that we can take any sort of signal that we find and decode it and make it a little bit more useful for us to hear. So, all right, let me scale back again. And if we want to start jumping through frequencies, the way we can do that is by going, clicking on the top of a number and going up. And we can see that we get these peaks. And for wide FM frequencies, you will see this kind of characteristic. You're going to see, let's keep going up, there we go. You are going to see a waterfall is what this is called, that looks like a bunch it kind of looks almost obviously like a voice fluctuation. Like when you listen to, when you look at like the waterfall for like a recorded voice. This doesn't quite look as linear as an AM frequency transmission, which is just going to be a line that's kind of like moving and squiggling. But this is still going to be pretty clear that there are voices on this, or that there's a rise and fall of audio. And if I were to tune into this, let's see, wide FM. Let's see what it sounds like. Nice.
Hey.
Let's not get a copyright strike.
Yeah, exactly.
All right, so there's even some stuff that's a little bit harder to listen in on. Can we hear this? Barely. So for something like this, there's a lot of interference here. And there's ways that we can clear this up using some of the built-in tools. Although I want to find a station that's not doing commercials because I hate commercials. How about this one? This one's kind of weak.
I wish there were ad blocker for the radio.
Yeah. Nice. All right, so let's turn it down a little bit. How can we improve this signal? Well, if we go to audio, we can see that there's some stuff we can do to help filter it. So let's unfilter it. See the difference, if there is any. Not too much.
It doesn't need too much filtering, I feel like, because that signal is pretty strong. So filtering is going to maybe help you distinguish if the signal is weaker or there's more background noise.
Oops. Okay, so we can adjust the display, but I don't want to do that. Let's do audio noise reduction. Let's try enabling it. Wow, that sounds a lot better. Let me turn it up.
No, it sounds like washed out. So it's...
Okay, before and after. So, before. You can kind of find a balance between it sounding like underwater and staticky. So there's also IF noise reduction. Let's try it. And Baseboy, nice blanker.
What
Let's
is
try
this? Okay.
Okay, so I'm going to go ahead and stop this again before we get a copyright strike.
Yeah.
But you can see that what we can do is we can start working with these tools to identify what the source of the interference is. And even though this is not as strong as some of the other signals we're getting, we're still able to lock in on it and start finding interesting stuff. So look at this. What I really like about SDRSharp is that they have some of the license spectrum actually labeled. So we can see that there's an air band over here.
Yeah.
So we can see the barrier between something that's, just for civilian stuff all the way over to stuff that's more going to be things that are for aircraft or stuff like that. When we're upstairs, we're actually able to listen in on the airport information. What's this? So we can see we have a transmission here. We can zoom in on it to try to see what it looks like. It doesn't look like much is being broadcast, but let's see what's going on. We can focus in.
That might be a digital signal.
Could be. Or it could be radar. Hey, it crashed. Windows people, how do you
Nice.
do this?
Yeah.
Opening it again.
I don't know why it would have done.
Okay, well,
Yeah.
it's working.
This particular piece of software can be a little hit or miss sometimes, but you can listen to a lot of other things.
Is
like
this you? Is this you, my friend? I've returned.
I've returned to crash again.
You will not defeat me. Okay.
Yeah, I think like one of the better applications for this is like listening to various radio stations for governmental radio stations. Like you can listen to police and fire dispatch very easily. You can listen to, as Kody was alluding to, air traffic control. You can even hone in on specific frequencies for like the regional control versus the local airport control. There are particular applications you could think of as a security researcher using these for. So, for example, if you were to watch our previous live stream on ADSB hacking, ADSB is one of the methods that airplanes use to communicate their location to each other. And SDRs are ideal for capturing that communication. But also you can listen to the airband, with the rest of the airband, which is actual voice communication. So ADSB is just like, oh, here's where I am. But with SDR like this, you can actually listen to the pilots communicating, and that can give you better insight on, oh, hey, the president's on board Air Force One, or if it's not using the call sign Air Force One, then it's not actually got the president on board. Stuff like that.
We just passed the marine. We just passed the marine layer.
Oh, hey. Yeah, so that would be more around the ocean and stuff. You can use AIS, which is basically the shipped version of ADSB, where they're broadcasting.
Oh,
their
to find
location.
ships.
Yeah.
Interesting.
That's very fun to do. And what a lot of people do is they'll make radio stations with multiple of these SDRs. So, for example, you can take an SDR like this, plug 2 or 3 of them into a Raspberry Pi, and then you put them up on a hillside somewhere. And so then you're able to simultaneously get like ADSB data, and then the air tower data, or the voice from the air tower, and then multiple frequency bands that they might be communicating other data or voice signals on. And then there's like ACARS, which is basically like text messaging for pilots. Essentially is the way I would kind of frame that. I'm sure that I'll get criticized for that analogy, but it's basically texting. Like, whenever they want to send out a report that's like bad weather in this area or whatever, stuff like that.
So like semi-automated messaging.
Right. You can also use SDR like this to listen into cell phone signals and other communications like that. However, you have to remember those signals are encrypted, and that's where you would use this to record those signals, and then you could use something like a new radio or another.
Hey guys, look,
Decoding.
military air.
Yeah.
That's fun. So you can clearly see here that we're receiving some sort of military air transmission. Sounds important.
Yeah.
Yeah, if you want to like be able to locate some stuff that's like pretty crazy, one thing I really appreciate is the ability to listen in and start seeing things like military air transmissions or other sorts of stuff that you think you wouldn't be able to see, but you actually
It requires slightly more specialized software, but there are a lot of old satellites that you can actually receive data from. For example, like the NOAA satellites, whenever they fly over, they're sending live images of the Earth. They're so grand scale you can't really see any details, but it's meant for tracking weather systems. So if you have the right kind of antenna and you point it at the sky when it's passing over, you can receive those images in varying detail depending on how good you are at tracking the satellite across the sky, because it's moving pretty fast.
Wow, the military has a ton of radio spectrum.
There's also, the military gets to use all of that. There's also pirate radio. So there's old radio satellites meant to act as repeaters in the sky that people have discovered that they can just send radio transmissions to and get them bounced back. So that's definitely something fun to look into as well. And when I say specialized hardware, I'm generally just talking about antennas and for satellite-based stuff, tracking. So some of them you can do it by hand, but it takes some practice. So for the majority of them, if you can spend $100, $200 and get like a little motorized tracker, it helps a lot.
Okay, so what about transmissions? If we want to listen to a point-to-point transmission, what would that actually look like? Well, it just so happens that I have a radio here, which I can transmit on.
Yeah.
All right, so let's say that I want to just send a message, and I bought this radio off the internet, and I'm like, sick, no one's going to be able to hear me. All right, Michael, I have a secret message for you.
Okay.
All right, it seems like that message got through. We weren't able to listen in on it, but let's investigate a little bit further. So if we zoom in, and if I hold down the radio button, we can see that we are in fact tuned in. What's going on here?
Yeah.
Well, it looks like, well, for one, I don't have the audio on. And for two, even if I did, well, it looks like I can hear most of it, but there's a lot of noise. So let's see what we can do about that.
I want to test something else out after. So when you see that peak, you also see peaks equally spaced out to either side. If I'm not mistaken, that's actually harmonics.
Oh, well, that's pretty cool.
What?
Well, no, what you said.
Oh yeah. So if I'm not mistaken, you should be able to tune into those harmonic frequencies and actually receive the signal as well.
Oh.
So it's creating a sort of resonance in the electromagnetic spectrum based on the signal frequency that he's using.
So usually you can set like a limit for the noise, so it stops making this awful noise all the time. But in this case, I don't know how to do it. So instead, I'll just show what we're doing with this. All right, so if we switch to wide FM, and we try to talk, hello, 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 it doesn't go through. And that's because it's decoding it wrong. So it needs to be narrow FM, and we also need to match it to the for the actual transmission we're trying to grab. So hello, hello, hello,
You seem to be
hello,
off.
hello. Yeah, I am off a little bit. So if I want to fix this, I can reposition myself over here and then drag this until I have the majority of the waveform right in the center. And now I can actually hear it. And it's a little bit frustrating that in SDRSharp, it like decides like for you where it needs to be. I think this is supposed to help with it, but it doesn't seem to.
I think if you click the numbers up there, you can.
Oh yeah, I can. So all right, yeah. Thank you, Michael. That is how you do it.
Yeah.
Okay, so to adjust this, what we can do is we can.
No, that's way too wide.
You never know.
It's gonna be.
You can do all
like
sorts
in the
of stuff.
7.
That? All right, there we go. So you can see that these are like fine tuning the direction. There we go.
Yeah.
Just like that. And now we are exactly where we want to be.
And can you turn the volume up just to make sure they can hear?
All right, so let's try transmitting our secret one more time. Michael's the dingus.
Oh my god. That resonant.
Great.
Noise. Yeah.
All right, so clearly this radio doesn't offer any sort of protection from snooping whatsoever. It means that anybody who's listening in with this really cheap piece of software and even cheaper Windows computer can listen in and discover what you're talking about. And this actually does work on a Raspberry Pi as well. So keep that in mind, that there are some radios which will actually encode stuff, and there are also radios which do not. So if you are in some area where a lot of people are using radios, I found in Los Angeles, there were a lot of people mostly speaking Spanish using these radios, and then people speaking English who worked at restaurants using them to do bus stuff. Here, Walmart uses radios, but they're actually encoded, so we can't hear what their associates are talking about. Yet security teams frequently do not use encoded
What
radios.
I loved is back in my hometown, you could just listen to the police and even like their tactical radios and stuff. So I love that the Walmart employees have better security than the police station.
Yeah. Yes.
Before you leave there, do you want to try my hypothesis real quick?
Well, I already crashed the program, and it's fatally crashed.
Good job.
Yeah. So thanks, Windows. Windows people, I'm so sorry. So why don't we switch over to your screen while you talk about whatever while I restart. And instead, I'm going to go into Linux, and we're going to do this process with a Linux.
Oh, wait, I need
this
a
is
second
planned,
to switch my screen over.
Yeah, do it. So, all right, what we're going to do is run this again, but this time we're going to, we're going to run it in Ubuntu, and I'm going to show you guys, oh my God, the instruction of reference memory memory cannot be written.
Do you still want me to switch over to my screen?
Yes, please. Because it's
We're
going to
probably get, here we go. But yeah, so something I highly recommend you all do is check out the RTL-SDR website. So they're one of the common manufacturers of these cheap SDR dongles, and they really have a lot of great articles about various applications of SDRs like this. So, I mean, down here you can see some of the scanner applications. Some of these I was talking about. So, you know, there's sniffing GSM, or basically listening in to certain cellular signals. With these various softwares, they'll have videos. They don't really write any articles themselves, per se, except for like the quick start guide. Mostly what their website does is just kind of collect information from around the web about these various applications.
All right, we can switch back whenever you're ready. All right, so now I'm in Ubuntu. I've switched over, and we're no longer running in Windows. So we can use some tools that I think are a little bit easier. I forgot to show you guys DSD Plus, but it just runs in the background and can't see anything because we're in a basement and can't see anything. So we'll save that for when we can actually get it running and show you it decoding speech. All right, so let's say that we're on Ubuntu. We have this RTL-SDR and we want to get started. Well, there's two programs that are generally used to do this. One of them is GQRX, and the second that I just discovered today is CubicSDR.
Yeah, there's a lot.
So let's start with that one because I know the least about it. So if we open CubicSDR, it's going to go ahead and query and look for the device. And Ubuntu recognizes this right off the bat.
So you didn't have to do any drivers.
Yeah, I installed RTL-SDR. I installed GQRX, which I think installed the RTL-SDR, or at least some stuff related to it.
That's really nice.
Yeah, but aside from that, I didn't have to go through all the driver steps that were all sketchy that Windows computers have to. So here you can see it listed because it's plugged in. I can select it. Go away. And I'm able to then start it. And look at how sexy this interface is. I feel like I'm in space.
I do feel like I'm a little lost. I like the SDRSharp interface.
What do you mean? Look at this.
Better.
How can you not love this? Great, I do need to turn it down. Okay, so I love this because it looks like I'm on the bridge of a starship, like Intercepting. And you can also see that right here are the different modes. It's big, bad buttons. They can just click around and start listening in. All right, we've identified something cool. Let's turn it up. All right, so we've found a frequency we're interested in this weird little blip I'm going to ignore. And it's really, really clear what's kind of going on here. I can do the same sort of manipulation where I can drag it in a little bit, or I can at least try to make it skinnier and focus it in on the part that's relevant, I hope. Maybe. I think...
Are you lost?
No. It there's like a minimum that I'm like hitting against with this particular type. But let me see if I can bring up the volume again.
Oh, that might have been what was crashing SDRSharp before. It didn't really have a good way to prevent you from going under that minimum, so it just crashed instead.
That would be funny. What a weak program. All right, so here, I believe this was actually something that I could hear upstairs. This actually was the, I think the airport information or something like that.
We're
can
relatively close to an airport.
Yeah. So I think that's what this is. But as I go through, you can hear it trying to decode the data in various different ways. And you can monitor it right here also to see exactly what it's doing.
And a lot of times, once you have done this for a while, you'll be able to look at these waterfall graphs and pretty quickly tell what encoding they're using.
Yeah, so let's do that. So let's go around a little bit and take a look. So I'm going to start moving around the frequencies a little bit and see if we can discover anything of interest. Let's see if we've got something going on here.
Because with like FM and AM and those, you'll actually be able to see kind of what looks like a voice wave on the vertical axis.
Interesting and spooky. So yeah, one of the things I want to show is, if we can, it's a little bit hard to again show in a basement, is the difference between types of transmission. So this, Michael, what is this? Right here. What is this waterfall?
That might be digital, but it might be.
This is going to be
FM
this is
station.
wide FM, and
Yeah.
I'm gonna place my bets. Here we go.
Yeah, and if you widen it out a little.
Yep. It's just random radio, and I can go over here and over here, and it's the same situation.
Yeah, so a lot of these radio SDR software tend to start you off on FM stations because it's the most easily apparent for everyone. But it is kind of fun, like searching out the other signals, and then but something I recommend highly is like Radio Reference and other websites like that. They'll help you figure out like what's going on which different frequencies as you kind of scan around, because it's not always apparent just listening to them like what you're actually listening to.
Oh, wait, why won't you stay? All right, so I'm just going around listening in on some other stuff here. Whoa. And again, you can
a professor who sort of wistfully
basically go through and find out which is the correct way to decode this by just kind of trial and error. Now, this doesn't have immediately like the amount of stuff just in your face as the other program we were using did, but if you go through the different options, there are a lot of things you can do in order to help out with reducing noise and other stuff. It's easy to start recording. There's you can do like bookmarks and stuff like that allows you to bookmark radio stations of interest. So if you find something that is
so
cool,
like the police station, you can just bookmark, dispatch, listen to them.
Yep, it even has recents. And this is the one that I believe I could hear upstairs, but we're just unfortunately too, I think we're too in a basement for this to work this time. I really wish it would though.
Yeah, we're getting pretty close on time.
I just want to hear a human voice.
I mean, you've heard the FM radio station. You've heard the...
Wait.
I hear something
I hear.
there.
Yeah, so we could clean this up if we really wanted to. If like Michael was like touching like the antennas and like whatever, we like moved it away from sources of power. Also, that would probably help. But let's go through our last program. So you can see that CubicSDR is pretty cool. It was pretty easy to get set up. Let's do GQRX.
Yeah, and something else fun to experiment around with SDRs is the fact that your cable, I mentioned earlier, like TV cable, since that's basically a radio signal, that's what your modem is decoding, you can actually plug in your cable TV to your SDR and look at what's going across the cable lines. And so in some areas you can actually see like the internet signals of your neighbors and other communications like that.
All right.
You can't decode them, but you can see that they're there.
All right, so here we're going to select the Realtek device that is our RTL-SDR. We're going to have all these settings should look just like this, except I'm going to change my virtual sync to my built-in audio analog stereo. I was using the virtual sync because I was trying to decode this for you guys, but again, it didn't work. Let's press OK, and we should open GQRX. I like the interface of this most of all because I'm most familiar with it. And then we can just press the play button to start. All right, so GQRX, very straightforward. Oh, look, a frequency I'm interested in. Click on it. Okay, cool. I can expand and close. I can zoom
I
in.
like that waterfall. That seems
Yeah,
a
I
little
can
cleaner
adjust the
without it.
gain very easily to jack the stuff up if I really want to hear what's going on here. What was that station that I just tried to go 130 something? I'm just hunting it now. So let's see if I can do this. So 131, 132, like we're poking around, we're looking. Looks like there's something at 132.6.
If you poke around the ham bands long enough, eventually
there's
you'll
always
find someone using Morse code.
We can go to input controls and FFT settings also to adjust what we want to look at. If we want to zoom in on the frequency, we can do this. And oh my gosh, this is the most trash signal.
Yeah, I was gonna say that's pretty weak.
Let's narrow in on it. It still sounds like trash. And here, if we want to go to input receiver options, then we can choose how we want to decode it. So let's say we want narrow FM. I mean, it still sounds terrible. But we can start to hear something, at least. Trash. Again, trash.
Yeah.
But look, it seems to be easier to work with the GQRX, at least for me, because I know where all these dials and tools and stuff are. So navigation works pretty much the same way. You click on stuff like this in order to change frequencies. You can go up very easily. You can go down. And if you're frequency hunting, it's just this. You're just clicking through. You are looking for spikes and things that look like one of two things. Either a transmission that is analog or AM, which will be spikes in power, or something that's rising and falling with human voice. Like, look at this. This is boring. There's nothing here.
Yeah.
This doesn't even seem to be digital. This is probably like a beacon or something like that. So this doesn't interest us. We don't care about this. But if we keep going, I'm sure we'll start to see something that has the characteristics we might look for in a transmission that interests us. And now we're getting more into like signals intelligence. Look at this. What's this? Let's go over here. So if we zoom in on this cluster of frequencies, we can see that there's digital data being sent here. This little waterfall, this like squiggles and stuff, like this is some sort of information that's being sent. And it doesn't look like it's human voice, but it does look like there is something a little bit, get out of here, a little bit more interesting. So my advice is if you're just getting into this, go through the channels until you find stuff that allows you to start decoding it in different ways. Don't bother around with some of the harder stuff, but right here, this, let me zoom in. This is something that's a digital waterfall. And this is the beginning of what you might expect to see on a walkie-talkie that's encoded, like a police scanner that's like actually encoded or encrypted. It'll look something like this. It'll probably be a bit stronger, maybe a bit wider as well. But around certain frequencies, you'll start to see periodic transmissions that look like that digital waterfall. And these periodic transmissions are how humans communicate. They don't talk forever. Like you'll see a spike like this. See this little one right here. Let me center on it. And it'll last for a while, and then it'll terminate. And then there'll be another one that goes for a while, and then it terminates. And they won't always be the same. Now, the difference between a human transmission is and a machine transmission is, again, human transmissions don't follow regular set patterns. They go at random intervals. They also don't do things perfectly spaced apart. So if you see something that's a repeating pattern, probably not a human. But there's a lot of ways you can start finding things that are either I guess I would call it like a band of interest where like maybe a bunch of different city services are all communicating, and you can start to zero in and find out which of those transmissions you can listen in on and which ones are actually useful and appear kind of repeatedly. Because also you might just get some guy like driving through your city in a truck, like talking on CB radio, and then he's gone forever, and like you just don't hear from him again.
And if you do really get interested in the signal intelligence side of this, RTL-SDR, that website I was showing you and the maker of the product that we're using right now, actually makes another version, which is 4 of those radios combined. And what it allows them to do is synchronize time. So you can have 4 antennas. And by timing the difference in when each antenna receives a signal, it allows you to
Hunt down
get
the
a
receiver.
direction. So you can do fox hunting. So essentially, if you were to attach that to a GPS, particularly like a RTK, highly accurate GPS, then you would be able to go around and take 3 location bearings, and assuming that the signal is remaining still, then you would have a very accurate point as to where that signal source is coming from.
I'm just saying if there's anything on 666, that would be a very spooky channel. There's nothing, thank goodness. But yeah, so, okay, I think this is probably a good place for us to leave off, unless I find something really cool and spooky within the next 10 seconds. But if I do, I'll
I already
let you know.
switched away from you.
Yeah, I know. I'll tell you to switch back if I find something
Sad
amazing.
days.
But again, we're in a basement, so it's a little bit difficult for us to find anything too cool. And this also does tap out at a certain point. I think it's like 1,200 megahertz or something like that.
Yeah,
It's,
1200-ish megahertz.
it becomes, frozen and
So
crashes.
you're not
and
going to
doesn't
use
like
this
it.
to spy on Wi-Fi 2.4 gigahertz.
No, you totally can.
Can you?
Oh, no, you can't.
I was going to say, I think the HackRF
you
has
can
enough
you can use it to spy in planes, but not that.
Yeah.
Oh, also, Michael, so if somebody wanted to get in on like a software-defined radio and they wanted to do it for free, you don't happen to know of some way for them to do it, do you?
Yes, I do know some ways. So if you are...
Wait, sorry, that aren't stealing from a store.
Correct.
Okay, go on.
Yeah. So a lot of the airplane tracking websites, like Flight Radar 24, and I forget the other one, FlightAware, and there's probably another one or two, will actually offer free flight tracking hardware to certain people in certain regions. So you can go to their websites and apply for that hardware, and that hardware is just like an SDR plugged into a Raspberry Pi. So, I mean, obviously you would use it for what they want you to use it for, but, I mean, you could maybe commandeer it for a couple hours here and there and use it for whatever you want to, right?
Or, I mean, whenever you want as well.
Yeah.
Yeah, so it's pretty cool that there are ways of getting these for free, but again, they're really cheap, and you can find them on Amazon and other services for next to nothing.
Yeah.
So if you want to get started using some of the programs that we've gone over today, obviously we've shown that you can do this on Windows, you can do this on Linux, you can do this on Mac OS. It is really easy to get started with this little RTL-SDR. So before you jump all the way in and get like a hack RF that's like $300-400, maybe try one of these out and see if this is something that's fun, if you enjoy doing it, because the SDR radio community is really big. They have a lot of really cool, really interesting projects. Then I was actually going to do a different project. We were going to do something where we take a Raspberry Pi and we take over a radio frequency by broadcasting something else on the same frequency, which is really cool. But I would have to show you guys how to listen in on the radio frequency first. So we decided to go over the basics of SDRs, and in a upcoming episode, we will actually go over how you can abuse this using a Raspberry Pi to take over a radio station, which is really cool, but requires a little bit of knowledge of how
And that's
software-defined
completely
radio works.
legal to have your own little radio, FM radio station. Because
No,
I know,
it's-
like...
No, it's not.
No, it's not?
It is not.
No,
No.
I know, like, people who run, like, Christmas displays and stuff like that will have, like, little FM radio stations that broadcast the music for their lights display and stuff.
Yeah, this is different. This is a hack, and it
Okay,
is not,
gotcha.
and is not strictly speaking legal.
Gotcha.
The way we are going to show it is legal because we're not going to put a antenna on the Raspberry Pi, and that means that the range of this is going to be reduced to a couple of feet, which is perfectly fine for demonstration purposes, but not enough to get in trouble. However, it does broadcast on a bunch of random frequencies, meaning like you're going to see this all over the place on frequencies that it absolutely should not be leaking onto. So if you were to put an antenna onto it, yes, you can take over a radio frequency, but also no, it's not legal to do, because unfortunately this way doesn't have a filter on it that prevents it from leaking into other bands, and that can cause interference and problems. So while it is a really cool proof of concept and it works locally, and we'll show you guys how it works so you understand how the attack works, do not go around doing this to just randomly take over radio stations, because it does cause side effects, and it can interfere with things like medical equipment or other stuff that relies on certain frequencies. So
yeah, but if y'all are interested in SDR stuff, definitely let us know in the comments below. We can easily do some stuff like he was talking about with the FM hacking on a Pi. We can use GNU Radio to decode some of these transmissions. We could even get one of the quad SDR contraptions to do some fox hunting if y'all wanted. So just let us know.
Yeah. So I think SDR is really, really cool. It is not always easy to do stuff like figuring out how to decode digital speech. Man, it is not easy to do on the setup, but it is still something that I would love to do more often. So if you guys like it, let us know and we will. So that's all we have for today. If you like this content, make sure to check out the YouTube channel where all of this is recorded. We get around to answering all of your questions either in writing or on the live Q&A. So go ahead and if you have a comment, if you have a question, drop it on the YouTube channel. That's SecurityFWD on YouTube. And also check out some of the other great content that Varonis has. If you've seen our guest Killian, he also has his own show that he's doing on the Varonis channel, which I believe is Threat Update, which goes over a lot of really cool threat intel that Varonis gets by working with tons of really big companies and gives you some insight into the threats that are actually happening now. So
and there will be a link to the playlist up there.
Yep.
After a while, after it's been on YouTube and I have a chance to actually put that link there.
Yep. Cool. All right. So thank you guys for joining us today. Hopefully you will join us again, and we'll see you next time. Bye.
All right.